Okay, so I think we can start now. So everyone, welcome to Memgraph Community Call. We have people joining. Hopefully, until I'm done with this introduction, everyone will join. So first of all, welcome everyone to Memgraph Community Call. Today, we have Martin Vo with us. He's the CTO of Paysure Solutions. So Martin has been a member of our community for a while now, and I'll leave it to him to tell you a bit more about himself. And today he'll tell us how they integrated Memgraph into their real-time payments authorization system. I think this will be really interesting because this call will focus on the struggles they had with Memgraph and how they resolved it. And I hope that everyone will find value in this and really learn from Martin's experience because it's really good. If you will have any questions during the presentation, please leave them in the questions tab. That's ideal, and I'll read them afterwards after Martin's presentation. There will also be a couple of polls posted as well. You see the polls tab underneath, so please keep an eye on them, and if you manage to respond to them, that will be awesome. And yeah, I think that's basically it from me. I'll leave the stage to Martin, who already shared his screen. And yeah, Martin, I'm really looking forward to this presentation as well as all the other people, I think. So yeah, the floor is yours. Thank you.
Yeah, thanks, Catherine, for the introduction. Hello, everybody. In this talk, I would like to share, as Katerina mentioned, our journey in the first part. Talk about our use case, because I think it wasn't a standard way how to use Graph Database. It's not a social network where we just query people and calculate likes. And in the second part, I'll focus more about our journey, about obstacles and challenges we faced and how we solved them. The motivation of this talk is to give you some ideas, what does it mean to run Memgraph in production, and some tips how to make it as robust as possible. So before diving into the topic, I would like to quickly introduce myself. I try to don't bore you too much about myself. So really quickly, after my studies, I've continued working on AI models for classification of some objects in neurons, let's say. Then I moved to freelancing as a data scientist, then did some research development, managing and running machine learning models in production and building some products and softwares around that. And then I moved more to software development and basically removing more AI and science names from the titles and starting doing pure software development. And then I did some leadership roles, and now I'm here as a CTO. I like Rust, functional programming, architecture design, now even graph databases, and also chess and swimming, bouldering, and long walks in rain. So Paysure Solutions, we started in 2017. We were funded by two ex-insurers, and that's why we started with clients in this domain, because we have really rich knowledge about this domain, and we saw that there is lots of opportunities to innovate there. But basically, we build products around our capabilities to control payment authorizations, which means that if you have card or other way how to pay, we can basically determine if the payment should be authorized or not based on some data, as your insurance policy, for example. So before talking about our authorization service and our queries, I'll do a quick introduction to the payments. So this is a flow how it usually is when you try to pay. For example, you go to buy coffee at a merchant, you tap your card to terminal. This terminal is provided by the bank from the merchant, and basically the request from the terminal to the merchant contains the card details. Basically, anything you see on the card is transmitted via some NFC. You're talking about contactless, and then it's propagated to payment network and basically looking for the bank of the user. And once it gets there, the bank will usually do some basic checks as if the card is valid, if it's active, if the user have enough money, and then it will go back to the terminal and you see some approval or rejected signs. And with our use case, we are integrated basically with the issuer. So this payment authorization request is propagated to us, and then we'll get this 100 something fields from the payment network, and we can basically decide if we want to approve or decline based on some domain data. Integrating with payment network brings some challenges. One of these is that there is usually some time threshold we need to respond. With our first card issuer, it was 200 milliseconds. So if we are talking about some complex allowances, we need to ensure that we can effectively access this data and respond in time. And also we need to update the allowances so there is no overspend. So if somebody is clever and try to pay at two terminals at the same time, we need to make sure that the payment won't go above the limit for the user. So this is our previous architecture. I won't go into the details of explaining how did it work. I just wanted to give you an idea about the complexity of this stack. So basically at the top, we have the payment, we have some authorization platform, and we need to find if the card or the payment should be approved. And there is some challenges, as I mentioned before, that we need to ensure that they were overspent. So we had to lock cards. We used Redis as the locking service. Then we need to fetch the data. For that, we used Postgres before, then Redis. And then we need to store it. And storing to database can sometimes take some time. So we used the message queue for that. We just throw away the message and had some workers doing all the things, because after the payment, we had to aggregate the allowances table. And if you have some complex allowance shared with other cards, it means that we need to aggregate lots of stuff so others can go over the allowance. Okay, so we quickly realized that our approach wasn't ideal. Once we started having self-referencing tables for allowances, we kind of realized that we are trying to replicate graph database in sequential database. So we start looking at some alternatives. We tried several ones, and we spent most of the time with Tiger Graph, and we almost went with that. But we started facing some issues with stability, and some queries started to be slow, and it was really didn't feel stable. So we reached out to Tiger Graph support on multiple channels, but we haven't heard from them. And after we actually decided to go with Memgraph after like 5 months, we got a response from some lady on LinkedIn from Tiger Graph saying, "Hey, I heard you have issues with Tiger Graph. How can I help you?" So we had to wait several months to respond. So we realized that this is not way how we can go live with Memgraph. So I guess everybody knows the selling points of Memgraph, that it's so fast and so powerful. But for us, the speed was really critical. It wasn't about improving the user experience to load their posts on social network. It was actually important for us because if the query is slow, then we wouldn't be able to respond in time and the payment would decline by the payment network. Also, we had to ensure the atomicity, which means that there won't be any race conditions if we try basically store two payments to same elements, for example. So basically, it allows us to ditch the locking service because it basically locked the database for us. So we were fetching allowances of one card, and if it's shared with other card, then if somebody pays with other card, it will basically lock it because there will be some violation of this atomicity. So this is example how the allowance can look like. In this example, we have two tokens. Token is basic card because we don't have to have like cards. There can be anything that can initiate the payment. So if you are talking about like WeChat, it's QR code. We can do open banking stuff as well. So it can be anything. And in this example, these two allowances have parent allowances. So there is some structure, and each allowance or parent allowance can have some restrictions. For example, here we got some amount restriction or countries, merchant categories, and areas, and so on. So once we started writing the cipher, we realized that we can do much more than before with our queries to database, because before we just fetched the data from database and then did basically the decision in our authorization API. But with Cypher, we could express all of this in the Cypher, and at the same time, we could update the payment, accounting, and everything in single query. So there wasn't any need to execute getting data, storing data, locking things, and everything. So single query doing everything. This is random part of our query. Just wanted to point out some concept we were using, might be interesting for someone. Here we got where clause in the call after with, which means that this call block will be executed only if some condition is met. So in this case, only for authorized payments. We use asserts to enforce the correctness of the data in database. Something similar can be actually done with triggers. And other tricky part we kind of faced when we start working with Cypher is cartesian product, which was our nemesis when we started working on this query, because when you have more calls and one call return more rows, then the second call is executing multiple times. So for us, we mean to make multiple, for example, accounting entries. So we use asserts also to basically to reduce the size of the data. And then there's some accounting stuff, and yeah, that's it. We were running still Memgraph and Kubernetes on Google Cloud Platform. We're using Argo CD for deployment. And since we need to ensure that the data won't be lost, we are using snapshots, periodic snapshots, and write-ahead logs. And to be sure that this won't be lost, we have backed SSD disk there, and also we have multi-cloud provider backups. So in case Google Cloud disappeared, we'll still have the data and we are using authentication as well. And this is part where we had our first kind of obstacle or challenges, because before then there wasn't too much documentation for the Helm charts for Kubernetes, so we kind of struggled with that for a while, but it wasn't that complicated. And after a few weeks after, we found that there is even documentation. So it's nice that Memgraph is moving toward this direction. Okay, so our journey, basically all of these circles here are obstacles, challenges we encountered. Some of them we faced at the same time, so it kind of spiced things up a little bit for us. So we started with rewriting the query. It took like a month, and then we were excited about the query and about performance. So we ran some benchmark, and we expected miracles, but it was still slow. It was actually so slow that we would reply in time for the authorization request. So it was a little disappointing, but we quickly realized that we need to add indexes, and after we add indexes to nodes and fields, that it actually solved the issue. And then we spent some time testing the query, writing different payment scenarios, and we were kind of happy that everything worked as well, because issue in query means that we can allow somebody to pay even if somebody is not allowed to pay, or somebody in hospital trying to pay for the surgery not able to pay. So for us, it was really important to make it to make sure that the payment will work. And our client, which we went live with Memgraph, started around Christmas. So it was unfortunate for us because we started seeing issues with Memgraph. So basically every second payment caused Memgraph to restart, which caused the payment to be declined. So it wasn't too great. And fortunately, on Discord, the community was still alive even during the Christmas, and we got some support from the Memgraph team as well. They were really proactive and helped us to identify what's the issue. And we found that there was some seg faults in the console. And the first suggestion we got is to just upgrade to the newest version. And for us, it unfortunately wasn't the option because there was breaking change with Cartesian product analysis I mentioned before, that the behavior of this Cartesian product between the calls changed. So for us, it meant that we would have to rewrite the query and then had a few weeks to test it. And since everybody was on holidays, and even if not, then we wouldn't have time to do it in time. So we had to think about some hotfix. And the issue was the query was too big. It had around 1,700 lines of code. Actually, it was two, but it could be one. And basically overflow some stack in memory. And we had several calls with Memgraph team. They also prepared some debug image for us. And we found that we need to increase the ulimit parameter for the Docker image. And it solved the issue. So we eventually also migrated to the newest version. This was a little bit challenging for us because we need to ensure that if there is any issue during the deployment, we can still roll back to the previous version as we do with our services. But snapshots are not back compatible. So if somebody write data after we upgrade to the new version and then we want to roll back, then the old snapshots wouldn't work. So we have to make sure that this will not happen. Okay, so after that, there was just rainbows and unicorns, everything seemed stable. And then we upgraded our query a little bit, and we started seeing timeouts. meaning that the query took long. It actually took 30 seconds. And we timeouted basically. And we had other chats and calls with Memgraph team, and they helped us understand how the caching worked. We had caching before, but we didn't think about warming the cache. So if we, for example, restart the Memgraph, the cache was removed, or if we changed the query, then the cache was different. So we had to introduce workers, which basically cache the query when there was any change, which would remove the cache. And after that, we got back to our tens of milliseconds realm, and everything was fine. And the issue is the query plan creation, to be more precise. This took the most of the time. So after that, we saw the Memgraph Lab has some upgrades for suggestion for the indexes. So we saw some missing ones. So we thought that will make our query even faster. So we started applying these indexes, and Memgraph stopped working. It stopped receiving or accepting connections. And fortunately, it was on the stage, so there was an implication for the client. And we solved it by turning off and on. But unfortunately, this is not person and machine. So doing it with database in production, which is used by authorization service, is not that simple. But we had some exercises on stage, and we did it properly in maintenance video without any implications. Okay, so after New Year, we noticed that the queries start to be slow, like all the queries, not just the authorization ones, but all the queries we used to Memgraph, and it was like 20 times slower. And yeah, it was around 700 milliseconds. And we spent over 3 months trying to find what's the issue. Firstly, we thought that this issue with Memgraph. We debug all of our connections we are making. We spend lots of time with checking the networking. We did lots of networking tests between everything we have in cluster and other clusters. We try to use even virtual machines to replicate the issue. And almost we hired the external contractor. There's several meetings with Google Cloud support. And we almost migrated to Neo4j. We rewrote the query or updated the query so it's compatible with Neo4j, and we almost went to Neo4j, but we realized that even with this crippled Memgraph, the response time was still faster than with Neo4j. So we wouldn't be able to respond in time with Neo4j. So we were digging deeper and deeper. And we found that we caused it by ourselves by enabling the authentication. The service is not public, it's run inside our cluster. So there is minimal risks or no risk if somebody can access it, but we wanted to introduce another layer of protection. So we enabled authentication, and we didn't care too much about the cipher which is used. And by default, bcrypt is used, which is really nice, but it's really slow. And basically, after we change it to SAJ 256, then the response time was reduced to tens of milliseconds again. And the reason why we are creating new connections for every request was that we had issues with the clients, both in Rust and Python, because if there was any issues during the query, like issue on asserts or failure on constraints, the the connection will just hang out, and if we try to make another queries, it will just time out. So it was really hard for us to do it this way. So we basically create a new connection per request, but it might be already solved. But this is how we implement it for now. And eventually, we also find what was the issue with the slow query plans, and it helped us to read the documentation. Katarina and the team shared with us as, hey, we improved the documentation because we realized that it was missing some parts there, and you were struggling with this part. So this is documentation. And once I started reading through it, I found and sorry, I missed. Okay, so there's a different issue. There was lots of issues. So sorry, I'm confused myself. And because at some point it took 3 seconds, like locally, and then it's starting to take 30 seconds. So, okay, so I didn't confuse myself. Okay, so this is wrong. And then I found that we wanted to increase the size of the cache, but we were actually increasing the number of the query plans. So for each query, the Memgraph tried to be clever and optimize stuff and created lots of alternative solutions how to get the data, and it basically slowed the query. So after that, we actually reduced it from the default 1000 to 10, and the query started to be fast, even if not cached. It was around 100 milliseconds, and there wasn't any impact on the performance. So basically, it meant for us that we don't need any caching workers and ensuring that the worm is cached. We just can have, or we had this luxury to have even uncached queries around 100 milliseconds. Okay, so to wrap things up, this is the histogram of all queries we are making to, or the response time we are making to Memgraph. The first row shows the time for the connection to be established, and the second one for the actual query. So we can see that most of our connections are established around 2 seconds or milliseconds, and in average, our query takes around 1 millisecond, which is kind of impressive given what things we do during the one single query. I think usually we create like tens of nodes and relationships. So, and also we are working some nested allowances. So there is this loop going through everything until it finds the root. So there's lots of stuff going on there. And it was really challenging journey, and usually our developers said that they have love-hate relationship with Memgraph, and I think eventually it moved more to the love side, hopefully. And basically what meant for us that we don't have this complex architecture with lots of workers and message queues and dealing with failed messages, message queue and undelivered things and Redis and ensuring that all the parts are running and lockings and timeouting logs and everything. And we could have just one solution, one Memgraph, one query doing everything for us. And I forget to mention that we are not enterprise users of Memgraph, so we haven't paid anything to Memgraph, and still we got premium support. If I compare it to Google Hub support, which try to help us with the issues, we pay like hundreds of pounds per month, and they were just moving us between the teams, and we had to repeat them the same thing every time, and they weren't really helpful. So really glad to have this very supporting community, not just Memgraph team, but other people on Discord. So thank you for that. And that's it from me. Thank you.
Thank you, Martin. Yeah, this was really nice. I mean, I gotta say, it definitely hurts a bit when I hear these issues as a part of developer experience team, but I really do remember all of them. I remember when you and Pierre and other members of your team reported them, and when you how you were happy when you resolved them. So happy to hear that now everything is working fine and that you share this knowledge with the community. So hopefully whenever someone else stumbles upon similar issues, they'll also ask us on Discord or they'll see the solution that you made. Okay, so I guess we can head over to questions. We have a couple of questions from the community, but if I can start first with mine, just because they are more general, and then we can head over to the more detailed ones. So I was just wondering, there were also the conversation about the Redis and the chat. So can you maybe explain a bit more in detail why you didn't continue with Redis? So like it's a key value storage, and you said you replaced it with Memgraph. So how did you, why did you think that Graph was a better storage, and how did you see this, and why is it better for you?
Yeah, as far as I know, Redis doesn't have any like plugin or out-of-the-box graph solution. There was this Redis graph, but it's not supported. Yeah. And we actually were thinking about it, and we kind of designed our graph database in Redis, but it basically meant that we had to make lots of requests with Redis to basically get some data, then from that get some IDs of other node, then request it again and again and again. So there's lots of rooms for issues, race conditions, and Redis is really great as a key value store and really fast. And even with this solution, given its speed, it was kind of fast as well. So some solutions could be actually built around it, but it would be too complicated to maintain such custom solution. And also Redis doesn't have any guarantees about the shape of the data. And with Memgraph, we can have constraints we use quite a lot. We wanted to find a balance between the having restricted schema, because we kind of like it in relation database because you have these guarantees what data you have there and what are their values. But with the graph, you can do like anything. So we introduced this constraint for the places where we need to ensure that they are correct. And yeah, I guess that's the answer.
Cool. So having both flexibility of graph schema, but also constraints help you in your use case. Okay, so we have a question from one user. So other than writing your own procedures, what kind of graph algorithms do you take advantage of? So perhaps when performing analysis on transaction data, do you use some kind of graph algorithm?
No. This is something actually we can do during the payment, so there will be more about analyzing the data. But for the authorization process, we need to ensure that they'll respond and we'll know the decision why we failed the payment. So we could do something like this for some fraud protection and doing some AI, but usually when your payment is declined, you don't want to see that some machine learning model for that on 95%. It's fraud. You just want to see that you buy the coffee, but you had just insurance policies to doctors and pharmacies. So, but yeah, I think we didn't do more advanced stuff. Like the most advanced stuff was this wildcard query to go from one node to all nodes, following some relationships. So I'm sure if it qualifies as a graph algorithm.
Yeah. Okay. Cool. I hope that answers the question. So next we have a question from Johan. So how did you handle not duplicating payments? That's the first question. He has a couple of them, so yeah.
Yeah, there is basically two ways how the payment can be duplicated. One is that if we receive the same payment request authorization from the network, and usually there is the same identifiers, and for that we had constraints in place, so we wouldn't store such payment. And then it can be two payments which look same, but it's not possible to find if it's actually the same payment because it will have different identifier. So it can be somebody paying twice at the same time, and it can be actually fraud. And for that, we also have rules as well. So we can detect it, but this is something which needs to be agreed with the client because sometimes it's valid use case, sometimes it's not. So then it can be decided based on the fields, like merchant name and merchant ID and country and things like this, amount.
Okay, and second question from Johan, did you clear the graph of older transactions over time?
Not yet. We thought that the database will grow. At the moment it's like tens of thousands data, but there is no implication performance as far as we observed. So we are keeping everything there. But if there is any slowdowns, then it actually might be the option. But it depends on the setup because sometimes you can have some rules which are looking at the payments, historical payments for like a whole year, for example. Then you can actually remove the payments. You can aggregate it. This could be one option to squeeze it into one aggregated payment, but yeah, it's nothing we had to worry about at the moment.
Okay, and the third and last from Johan, did you model the graph with a temporal dimension? If so, how did you model the temporal nature of the payments?
What is in temporal in this case?
So like, do you have like time of the payment when it happened? Do you have some kind of date time or so do you have any kind of time dimension within the graph?
Yeah.
And if you do have, how did you model it? How did you put the concept of time in the transactions?
Okay, yeah, we got the timestamp from the payment network, but we have it just as a field on the payment node.
Okay, and did you use like what kind of data type did you use in Memgraph?
It's a datetime.
Daytime, yeah. So you use temporal data in Memgraph. You didn't, yeah. So this is just a small tip. Use temporal data if you can, because it uses less memory than string. This is a small graph data modeling tip while we're here.
Yeah, it was kind of tricky actually with the daytime because you convert it from the string, and if you match the format, then it's transformed into this time format. But we had some clients missing the format, and it was stored as a string. And then once we were checking the authorization controls during the payment, we were comparing daytimes with string, and it started failing. So basically, could affect even the payment if somebody created payment with incorrect datetime. So, but yeah, with the constraints, the triggers, you can actually enforce that it's actually the daytime, or even with the constraints probably.
Cool. Okay, I hope Johan Martin answered all of your questions. We have two more questions from Bassem. So he asked, how did you replicate the memgraph? Did you run from one server?
Yes, we don't have replications, if this is the question.
Yeah, so I think that's the question.
Yeah, it was tricky for us because we were exploring this setup, and usually you have just read replicas, and since we try to optimize, or our main bottleneck was the authorization query, which not just read but write, so it wouldn't make sense for us because we couldn't talk with replicas. We still have to talk with the master instance, and it was kind of challenging to ensure that in this Kubernetes setup we have that the replicas were promoted to master. but for high availability, this is something we'll probably try to explore more. But yeah, there is other challenges comes from that. So before that, we'll just chill and relax with what we already achieved for a while. But yeah, there is other places where we can improve it. To be honest, yeah.
Okay, thanks. So we have more questions coming in. Just for everyone watching regarding replication, so within Memgraph community, you can replicate the data and create a cluster. But regarding high availability, you would have to manage that yourself. But with enterprise version of Memgraph, we have high availability there. So just information for everyone watching. We have more questions. Why did you use a graph database where there is no need to use graph algorithms to solve a specific problem that is not by a general relational database? So basically, like, why did you even use graphs if you are not running graph algorithms?
Okay, that's a good question. We try to make it work without graph database, just with Postgres and Redis for like 2 years or over 2 years. And basically, the main issue is the self-referencing allowances or allowance tables we had to deal with during the payment authorization. So when you have different tables in second database, you can do joins. If you talk about the Redis, then you can have reference to other keys in one value of other key, and you can do hops easily between it and collect all of these allowances. So with Graph database, it allows us to basically, when payments come, we'll get all the allowances of the card, and we have like all of these allowances at the bottom, which are part of the structure, and basically it can run in the same time. So it's like the race horses going through the other allowances and like basically going to the root. And if one horse is happy and go to the top and all the checks are fine, then we match the payment to this allowance. So basically the answer is this this option to go or do this automatic basically between the allowances, and also if there's other checks matched to the allowance, then we can like start exploring them as well. And if there is, for example, some restriction for area, then we can hop to the countries, and this is something which can be done with second database joins, but not the self-referencing fields. This answered the question.
I think it does, but yeah, definitely. I also sent in the chat the link to Discord, so I recognize some of the names here. So if you will have questions, Martin is also on Discord, so you can continue the conversation there. But let me wrap up with another question from Johan, and I think that's it for today. Johan asked, how many payments do you need to process in a day, like in average? And he asked another question. So you only need to create small number of nodes to model the transactions in your use the ACID capability of Memgraphs in this concept. And what's the size of the graph? So basically, how many payments do you need and how large the graph is?
At the moment, we're running the Memgraph just for one client. So we, for example, our cluster like hundreds, thousands payments, and all of these have relationships to other attributes or nodes like country and accounting entries and everything. So it kind of adapts. So I think we are around like 10,000 nodes and relationships.
Yeah, I think that's. And did you mention how many payments do you need to process in a day?
Oh yeah, it depends, but usually like tens.
Mm-hmm. Okay, so I think thank you, Martin, for answering all of the questions. There were a lot of them. I would maybe just wrap up with one of mine for the end, and that would be, what tip would you give to Memgraph user on indexing? And the reason I'm asking this is because whenever someone joins the Discord, I think the first thing we ask is, did you index your data? So if you could give like a general tip or whatever you can regarding indexing in your case or in general case, what would you say to any Memgraph user?
Yeah, nowadays just to use the Memgraph Lab and try to run your query and go with the suggestions. But before we actually had to do it old-fashioned way, we look at our query, we try to profile it, and then we went through the profile and look for all the nasty things, that scan all and check how many nodes are there. So if you encounter like 100,000 operation for this line, so we knew that there is something fishy with Cartesian product, for example. So yeah, I think with the updates to the Apple app, sorry, the Memgraph app, it's quite easy to do it now because there is suggestions, and usually it helps if you look at your query to check what match statements you're using, what are the fields you are using to get the data.
Yeah, I think those are really good tips, and definitely what you said, Martin, like if you see scan all in your profile result, like do something about it, because it scans everything and it's really not good. So it's better to index some property or label to get a different operator as a result of your profile query. So yeah, I think that's it. We had a lovely time. Thank you, Martin. Everyone else is also thanking in the chat, and you had an awesome presentation. Thank you for joining and sharing your tips and tricks with Memgraph and your experience, as well as struggles that you had. And hopefully we'll get to do this another time once again and talk with you and everyone else on Discord.
Yeah, awesome. Thank you for having me.
No problem. Bye, everyone.
Yeah, bye.